As I'd mentioned, the session is going to be moderated by one of our very own at G.H.Scientific. He's a business analytics specialist at Nestle Central and West Africa region, as well as a global shaper alumni and of the World Economic Forum at the Whole Hub. He was the project lead for the Internet of Whole Things, codenamed Workbook, which was a project introduced to junior high schools to get them to work on the Internet of Things. In his free time, he loves to volunteer, and we can all attest to that, and work on quite a few personal projects of his. He does have a love for agribusiness and tourism, and if you love Sudoku, he challenges you to a game anytime, any place. So his name is Collins Gadawusu, and he considers analytics as his superpower. Collins, over to you, please.
Thank you very much, Dr. Tego. So everyone, welcome to today's session. So we are looking at interactive science moving from research to practice. And for this particular session, we are going to have the panelists. Our panelists are going to be made up of Nana Ama Yankah, who is already here, Kofi Ankobiah, and then Nana Akua Ankomah-Asare. Now, since we are looking at interactive science moving from research to practice, we'll have them introduce themselves as a way of practice. So probably we'll start with Nana Ama. You can introduce yourself to us, and then we'll move on to Akua and finally Kofi. So the floor is yours, Nana. You are muted, Nana Ama, so if you can unmute yourself.
Yeah, hello.
Yes, we can hear you now.
Okay, so hello everyone. My name is Nana Ama Yankah. I am the founder and CEO of Naya Naturals Limited. Naya Naturals is a brand. It's a manufacturing company that manufactures bath and body care products. Our brand is called Naya by Africa, and we have been in that business for about 7 years. Well, I'll probably say 7 to 10 years because I have my experimental stages before I even got into business. So I'm sure we'll talk about more of that as we get into today's session. I'm excited to be here, and thank you for bringing me on board.
Thank you very much. Great. Thank you, Nana Ama. So Nana Akua, can we hear from you?
Yes, hello. And hello to everybody. I'm happy to be here. I'm Nana Ankomah-Asare, and I'm the Managing Director of Primetime Limited. I do find myself in interesting company because I don't have a science background and we don't do science stuff, but we run science-based programs, and that's I guess why I have a link here. So Primetime Limited is primarily an advertising and public relations company, but we do all sorts, we double in all sorts of stuff, publishing, and then we do TV, radio and TV programs. Our flagship program is the National Science and Maths Quiz, which we've been running for the past 28 years. And then we also have the STEM Festival, which we started originally as part of the National Science and Maths Quiz, but this year, which we broke off to set up on its own. So nice to meet you all.
All right, thank you very much, Nana Akua. Kofi, let's hear from you.
Yes, hello.
Yes, you're live.
Okay, Naval Lieutenant Kofi Ankobiah. I'm a marine engineer. I've worked with the last 7 years. I initially served on board one of our fast patrol boats. Then we took traveling to quite a number of places, in Africa, going as far as Congo, Nigeria, and all that. Experience on board. Currently, I'm working as a naval architect at the Navy headquarters. The Navy, from I think 2 years ago, initiated a capacity building program into ship design and construction, and I was privileged to be part of the naval architect. So basically that's me. Aside that, I think when it comes to art as well, because I know G.H.Scientific science. I'm a graduate music lover. I produce music. I play every instrument that doesn't require too much energy. I've produced mix and master music as well. So that has been good. And then for, I think, Kofi Ankomah-Asare, I've mentioned that National Science and Maths since 2006. Well acquainted. Thank you.
All right. Thank you very much, Kofi, for the introduction. Okay, so Nana Ama, so in your field, what does it mean to move from research to practice? How does it look like? Okay, you are muted, Nana Ama. Sorry. Hold on, Nana Ama, I think you're still muted.
Mute. Can you hear me now?
Okay. Yes, we can hear you.
Okay. So the interesting part I didn't tell you about this is that the most science background I have is literally high school. So my college, I studied computer information systems, and I also have an MBA. So I started the brand just out of curiosity about skincare. And so from there in the last 7 years, I've developed about 70 different products. Now, wow. Most of what I've been able to do has been what I call curiosity about science and what you can actually do with it, right? And so for me, that is how practical science is. I feel like sometimes, well, when we think of science and research, we always think somebody has to be standing in a lab coat in a lab for science research and has to be done. But I feel like what we miss out on is the big part of science is discovery. And that actually starts at a very young age. When you watch a child that is even playing, if you give toys to any child, you see it punch it and push it and put it in their mouth. All of that is science discovery, and that's learning. That starts very early. I think what gets added on over time is when you go to school and then they start to explain to you that, okay, when you touch this and it's this hot, it's this temperature. When you do this is matter. This is heat. This is centimeters. This is meters. And so they start to put some structure to it. But what we tend to do, unfortunately, is we start to lose our creativity on the other side, where when we start to go too focused on learning the structures, and then we miss it. But I think a good part of what helps us translate science into industry is just being able to translate that, take that intuition, take that creativity, take that discovery, and then add the structures of science, which is, okay, when it's like this, what's the temperature? Then over time, you get to understand what all the different elements of oils and fats and how chemical reactions between things and what all of that means. And that's when science gets turned into what you call it, practical things, and then into industry.
Wow. Discovery, intuition, creativity, and then an element of structure. Thank you very much, Nana Ama. So, Nana Yankah, in the Ghanaian context, how is it to translate science into practice from research?
Well, that's a big question, and I'm not so sure that I'm competent to answer that well. But what I would say is that it's important. The research part is extremely important because you need to have a good idea what the situation is. Now, in my industry, which is mainly media, advertising, public relations, the research part tends to be just the academic part. It seems to be a big kind of divide between the academics, what they say, and what the practice is on the ground. And there are a few reasons that I think could account for it. One of them being that Ghana is a very small space and a very small market. So you realize that the practitioners tend to be a master of all trades, kind of. You have to know a little bit of, if you're in my industry as in advertising, you have to know a little bit about health communication because some of the jobs might require you to do some health communication. You must know something about graphic designing. You must know, you have to have a grasp of a lot of different areas because it's quite small, so you can't do kind of like a niche kind of marketing. Now, when we look at the research parts translating into the practicals, I feel that we don't do enough of the research as practitioners. I'm moving away from the academicians as practitioners, because when you are doing a campaign, you must base it on facts, right? On the ground. You will not be able to do a successful campaign if you do not do, for example, a baseline study. One of the things that I found out when I finished my master's and came home to work at Primetime was that we don't put a lot of emphasis on monitoring and evaluation. So, but you do know that research takes different forms. You do your baseline, then you have to do some evaluation along the line, excuse me, at different steps. It's good to do some research as the program or as whatever it is you're doing, the project is going on, and to do some end of study or end of project or whatever evaluation as well. All of that is research. And all of that is important because if you do not first test to see what knowledge is available before you start, then test to see how whatever it is you're doing is responding to the problem you're trying to solve. How well you did as opposed to what you set out to do, then you're not going to be doing very much and it's not going to be impactful. So that's where I find the disconnect. I don't know if I've answered your question well.
Yes, you
have. It seems like it seems like it is not very a very strong area for us here in practice, at least as far as my side is concerned, my industry is concerned.
Yeah, that is fine. Thank you very much, Nana Yankah. All right, Kofi. So, who do you think should be responsible for pushing the agenda of moving science from research to practice?
Okay, thank you very much. For who should be responsible, I genuinely think that it's not a one person who should be multiple. If I take the Navy, for instance, as an example, let me use our education in marine engineering, for instance, from the Regional Maritime University in Accra. And then we have other industry players. We are looking at Ghana Ports and Harbours Authority, Ghana Maritime Authority, Fisheries Commission. All these people have the way they work with the Navy and have the way we collaborate. If there is a research, for instance, on boat construction, the knowledge of the Regional Maritime University faculty and staff comes in very key, because those are the principles that would uphold the science you want to do. Say you want to construct a boat, that knowledge they have will be good. There are some industry players like the PSC Tema shipyard who have been repairing ships for a while, and then they have a graving dockyard. So the industry players' knowledge to or their experience in the field comes to bear. And then finally, I would say the Navy, for instance, is the end user, the main stakeholder in such a venture. We know how we want to operate, which terrain we will go into, what is the depth of the water there, what kind of risk will our personnel be exposed to. So typically for our kind of research we do, and trying to make it practical, you have academia, industry, and then the military specific requirements as well. What I see as a loophole is that we don't have too many industries cutting across. Very key stakeholders I've mentioned are in place. It will be easy to lead research in that respect.
All right, thank you, Kofi. So much more collaborative approach. All right, Nana. Particular product of yours. How?
Okay, so one thing I always say is that when you have to research and to develop anything, you usually have to start with the end in mind. So you have to have some idea on the end, what you are looking for before you even start any research into it. Because if you don't, then you're literally just digging around without any particular goal. But when you have, let's say, at the back of your cream or a soap or something like that, then you have some ideas about what you're looking for. If the first thing you start to do is understand what is going to go into those products, right? So once you understand what's going to go into those products, so let's say we are making a cream, right? So we know that we are going to need we're going to need some oils, we are going to need some emulsifiers, we are going to need some preservatives, we are going to need all of this. And this is stuff that you have to do some research on even before you start, because you have to figure out what is a cream, what goes into it, why does it come out the way it does? And why does this cream look different from this cream? What makes this one thicker? What makes this one thinner? So there's a lot of questions you have to ask yourself before you even get into even putting anything together or even deciding what to buy or what to get into. So that is the discovery, creativity, research, begin part of it that I always talk about. Once you get through that phase, then you get into the science of it, right? So once you say, okay, great, now I want to have in there some shea butter, I want to have in there some oil, I want to have in there, this preservative because it's safer than this one. Then you have to do some research about them and why those particular ones and the impact of combining them together. That's where the science part comes in, because then that way you are not trying and erroring literally with your eyes closed. So there is some trial and error that you do, but when you do it, it's not like you literally have your eyes closed and you're just dumping everything together to see what will happen. You have to have some sense of what you are looking for, so that as you're doing it, because nothing in the world is really completely new. The basics of science have already been figured out, and that's what we learn in school, right? So when you're learning chemistry or physics or biology, you are learning, even when you're learning about technology, you're doing technology research, you're still learning about the science of what happens when, to whatever, a negative and a positive something comes together, GPS, you're learning about signals and sounds and all of that. And most of these are things, basic science things that already exist. But in the practice of them, you get to figure out how do they connect and how do you, reuse that process, right? So no matter what you are developing, then you can go back and say, okay, this is what I'm trying to achieve. What pieces of science, what pieces of equipment, what pieces of learnings do I have to do around which products, which ingredients, which items? Then you can figure out, before you bring them to your lab and you start mixing and matching. Because when you start mixing and matching, that is where some of that trial and error and process and this didn't work out, let's try it, let's take this out, let's add this in. Or even sometimes when it works, you still say, well, this worked at 20 degrees. What will happen if the temperature went up to 30 degrees? Because you know that maybe it will be exposed to that. So even when things work or not, you have to constantly ask questions. You have to constantly poke. You have to constantly do if then else, or if this didn't work out, then what did I do wrong? And constantly writing down and monitoring and evaluating and coming back to what you wrote down to see what's working and what's not. So it's literally, once you do your initial research, then you bring in the things that you want to create. You need to create whatever product or item you want to do. Then you go back to now mixing them together to see what happens. And with that, sometimes you could go through several iterations before you get to what you're looking for. And, even sometimes, even after it works, you're like, great. Then 2 days later, the whole thing changes. And you have to come back and research what happened. Right? So science is one of those things that it doesn't stop even when the thing has been applied. If it was, sometimes I'll say, that's why I say to the people that I work with sometimes, that if science was, if things were literally done and once it's discovered, the practicality of it, sometimes there's an ingredient change. Sometimes somebody stops making something you need. Sometimes some some equipment that you need is not available. So you have to use a different type of equipment. So that creates towards something. So it's not all just in vain. So that whenever you're doing, you're still monitoring. You're still writing things down. You're still asking questions. You're still evaluating to an end goal, so that when you get there, you know you've gotten there. Or sometimes you may even put it on the market, and then people will come back to you with feedback that this happens when I take it to my house. And then you have to go back and understand the environment, that different types of environment that your products get into, and what the impact of that is, and then come back and reiterate your process. So it's this constant improvement and change and thing that happens literally throughout life. So science is life, science is discovery, science is research and application, and all of that. It's a continuous process that literally never stops. That's my, and then halfway through it, I have to pull it back and reiterate it, and it happens. Or some ingredients, depending on a supplier stops making it, so I have to replace it with another ingredient. So I have to go back again and find another ingredient that matches it. That's where my background that's where my research comes in. Now I need something that has similar properties, that has similar feel. That way I'm not changing the entire product just because I'm changing one ingredient. So some of those things happen, and then but it's a continuous process of engaging, improving, iterating, and then still with a goal in mind of what the type of quality of products, the consistency, and the the dedication that you need on the end. This happens everywhere, even in non-traditional places where you have people who are not scientists who are developing a soap, like the women who make glass soap, or those that make shea butter. All of those are science processes. They may not be doing it in a lab, and they may be using rudimentary processes, but somebody who literally takes a scientific approach to developing shea butter will go through the same processes they do, except they will record it differently. They will approach it differently. They may even use less time to figure out the end goal. So that's what our education does for us. It shortens timelines for things, and it improves processes. It improves structures, and it also brings in some consistency to what we do, so that we know what the outcome will be all the time.
Wow. So I guess we are all scientists in the making, because
we are scientists all the time, not in the making, every day, everything.
All the time, right? Okay.
When you cook, you are using science. You just don't think about it, because when you use one water, why does your soup get watery event? When you cook it at a certain temperature over time, all the water evaporates, and then it becomes stew, and then all of that is science. So we have to try to not make science so scary that people feel like you have to be some particular way to practice it. So once we make it feel more practical, then we actually get to see it in everyday life. I feel like that's when we're able to appreciate it better and use it more in our, and appreciate the benefits of it in the different things that we do.
Great, great. I think I have to pay much more attention to my tea making process early in the morning.
Exactly.
All right. Nana Akuya, how best help facilitate common grounds for media personnel and science practitioners for continuous partnership? How can G.H.Scientific help when it comes to bringing together the different actors within the space in order to promote research, moving from research to practice? You are muted, please.
Somebody has to unmute her.
Yeah.
Right. I think that this event is a good first step. When we come together and even find out that we actually need to do some collaboration with the media parts, I think that's already a good step, a first good step. Subsequent things that could happen could be G.H.Scientific organizing in collaboration maybe with the Ghana Journalists Association some workshops on to sensitize journalists on how to report even on scientific material or discoveries. I find that we don't have much of that there. I think it was in 2018 NSMQ, during our mentorship program, we met science journalist. He's a pharmacist with journalistic training, and I thought his session with the students was very interesting because he was able to show that there was a link between journalism and the science world, because once the scientists have come up with their discoveries, someone has to translate the findings into language that you, well, maybe not you, but I can understand. Because if the output is all in technical language, then you're not going to get ordinary people understanding what the communication is. And so there should be more of a should I say collaboration between these two areas. So we train scientists to have journalism so they can also do that that kind of work. I guess it's a lot more common outside in the West than it is right here, but we do need the group to bridge that gap. Otherwise, everything the scientists do will stay in their labs or on their research shelves and stuff like that. There will be nobody really to translate it into the kind of language that a businessman would understand and therefore be interested in sponsoring. So that could be one of the things that you could, as G.H.Scientific, could do. Some collaboration with either the Institute of Journalism, Ghana Institute of Journalism, or with the Ghana Journalists Association to introduce some courses like that, or yes, or facilitate something like that at the university level, so that somebody who is studying pharmacology, for example, or studying whatever scientific field, biochemistry, whatever, would have some training in media work or media relations or reportage or writing, as a way of bridging this gap that I'm talking about. I think it's something that you could think about.
All right, thank you. So Dr. Tego, you have your work cut out for you. Yes, and the G.H.Scientific team. Okay, there is quite an interesting conversation going on in the chat. And Kofi, I think a lot of people are engaging you, especially with regards to your military background and what is happening over there. Just tell us. I mean, someone wants to know if the military have a research unit and what exactly they do. So just give us a summary of the conversation that's been happening in the chat and what you've been telling people with regards to research in the military.
Okay, thank you very much. Like I've answered in the chat, if you've read already, we do have a whole directorate for research and development. We call it PR&D in Ghana Armed Forces, the Plans Research and Development. And I mean, exactly what we are talking about is what is done there. We look at, we first start with plans. In the military, we always look at mission requirements, your plans, what are your forecasts? I know so many people have commented about what the Ghana Armed Forces is even doing in Ghana now. But what we are doing now is essentially what we call the peacetime rules. I mean, we are not necessarily having any war or any imminent threats. Of course, there are other threats around us, so we have a way we deal with them. Peacetime, for instance, our focus is on socioeconomic benefits to the nation, although the military specific goals are there. So at this point, some of the things plans, research and development would want to do is looking at, okay, so let me use some parts of the Volta region, which were very mountainous areas, like Loba, Kleko, Tafiagome, and Co. Our focus there was to get the places motorable so that there are roads without going around the mountain. Some of them even literally have to go on top of the mountain. And the 48 engineers, for instance, is a unit that handled such construction. So they look at mission requirements. I mean, what do they need? They need a road from Loba Kleko to Tafiagome. So they'll go there, look at the landscape, all the geomatic engineers, everybody will play their role for science-specific research. And then they'll come back to, let's say, the Directorate of Engineering Service and say, we need a 48-kilometer road across this mountain here. And if you are aware, the 48 engineers has handled a lot of road construction in Ghana. And I think that is something we see. So in peacetime, those are some of the roles we look at. But for military-specific research, it is continuous. I mean, as I'm talking to you, today is a holiday, but I'm at work, I'm in my office. My office is essential. Special project is mostly research. And we have a few conferences coming up, so I'm here to play that role. I continue the comments by saying that every field unit has more of a research and development unit, either at their service headquarters, sometimes it's specific to only Army, to only Navy or Air Force. And then when you take it down to, let's say, a ship, like when I was working on the ship, some of the things we look at is maybe the ship was supplied with a particular filter for the main engine. But you realize that that filter is a bit, let me say, temperature-based. If the engine is coming from Germany, their temperatures are way colder. So the material that has been used for that filter has some tolerance for being cold, so they can use it in that region. How do we, change it so we can use that same filter, or do we require another material to create another filter that can be used in the engine, but now in the tropical zone in Ghana here? So yes, we do have a big research and development directorate here in Barcamp at the general headquarters, and it trickles down to the unit level. So everybody kind of plays that. Everybody kind of play that role of giving feedback on the equipment we use and how we can make it better. I mean, one thing that was interesting for me when I joined the armed forces was the rifles we used. I mean, it's not made in Ghana, but we always had to find a way to say, okay, this rifle has this issue, how do we correct it? I may not be able to spell out too much detail because the chat's comments, I mentioned that some of these things are very classified and are not really for public consumption, but we do. For the socioeconomic ones, I think in a presentation I may give later on in one of our breakout rooms, I'll go into some of those things and maybe a bit.
All right, thank you very much, Kofi. That is quite insightful. All right, so Nana Ama, sorry, let me just go to Nana Ama first. What are some of the challenges that are associated with translating research findings into practice? Let's take your space, for instance. You've developed quite a lot of products. What are some of the challenges that you have faced when it comes to translating
if you know what you are doing, if you do it the first time, it work. And or if you what you call it, then that's how we prove that we know what we are doing. But I don't because science and research and most of things, literally, like I said earlier, it's pure discovery. So every time you do something, you learn something in the process, which makes something, which creates something. That's actually how patents and other things around the world get created, right? Because people get to discover things as they are working on other things and then get to say, wait, I'm not sure if anybody has found out about this before me. So let me patent it and then let me be on record as the person that discovered this so that when others use it, they'll give me credit for it, right? So I think every time you do that, it sometimes can be a bit conflicting because you feel like, well, we already said this was going to, we already done all our planning, we've put all this in place, we've come all the way here, we are going to do this, and then you put it together and something goes wrong. Or you try to go back to several things, or you try to repeat something over and over, and then today something is wrong and you're like, oh, wait, what changed? And then you have to go back and then figure out maybe some of the parameters changed that you didn't even realize changed, right? So there's several things around those things that I feel like we miss out on in terms of how much science in itself every day, translating your research can become a whole exercise of trial and error and frustration, and seems to never end, or seems to never have, get you to where you want to be, no matter, even after you've gone through several iterations and things like that. So those become a bit challenging. Sometimes people get discouraged and they stop because they feel like they're not achieving whatever goal that they set out to achieve, right? But that is something that we have to realize that it is part of science, and then it's also part of how we get to discover other things and how we get to learn. And the learning is a big part. And the more we do that, the better we become at that thing, so that even when we finally achieve our goal, we can come back and say, hey, but while I was doing it, I found out something that I found out other things along the way that has actually made me better. So always realizing that it's a learning process, even in constantly creating something that you've already developed, right? Because some conditions may change, like I said earlier, or some supplier will stop providing some equipment, or some and I'm sure it happens in all different industries, even in the military, as Kofi is talking about. No matter what things they are doing, they don't always have everything they need all the time. And sometimes even there's the technology that exists in different other markets are different from the ones we have here, but we still have to come up with, then how do we make it work in these conditions that we have in Ghana here, right? Or even, in doing different things, we kind of bring in other people that have expertise in different areas to provide other information that we may not have, or to provide other insight into different areas that we didn't understand. As Nana Ama mentioned, that maybe it's a media person, you are going to do a story on this, but you're not familiar with, maybe it's about the environment, but it may be better to bring an environmental scientist into the space who will then look at it and say, well, this is what I am, based on their understanding of environmental science, since that is their area of study, they can provide a perspective that can actually make the entire conclusion better. So sometimes being able to bring other people from different areas into that research process, being able to engage other people, or use different equipment and have to learn how to reuse, do things with things that you don't have, all become part of the process. That makes it challenging, but it's also becomes part of the learning that I think should encourage us to that it makes us better. It actually doesn't, it shouldn't discourage us to stop, but it should actually encourage us to make that helps us become better as we go through a process of creating things or developing anything.
Great. So it's a learning process, and it's not a straight cut-out process that we may perceive it to be. Okay, Nana Yankah, you talked about collaboration and how we need to collaborate. Now, in doing this, are there other considerations that we need to bear in mind when it comes to translating science to from research to practice? In terms of the collaboration, are there any specific considerations that we need to bear in mind?
I don't know if I could ask you to be a little more specific about.
Yes. So in terms of context, you are collaborating, let's say the media, you happen to be in the media space and you have to work with other scientists. Are there any specific considerations that we need to be aware of if we have to work together as a team to move from research to practice, apart from just coming together?
All right, I'll attempt all questions. I'll attempt this. So what I think is that in coming together, doing this collaboration, we're going to have to look at who the end user of the particular, if it's about a product, I don't know if we want to do it in general terms, like teaching people how to report scientific knowledge, or if you are going to be looking at it as maybe a specific project and teaching, because you have to start at you have to start from some point, right? But I'll throw this in generally, that I think that you'd have to look at who the end user is. In your collaboration with the media, are you looking at letting everybody understand? Is it a specific kind of person who has to understand this, or who the information would be useful to? If you look at our Ghanaian context, you realize that a lot of the time you will have to do it in different languages as well, not just in English. So I think that in communicating these projects or results or whatever it is that we are communicating, in collaborating, there should be an effort to translate into local languages, because that is when you actually get down to the grassroots. There's something also that I think can be done. It's starting young. And let me give you this little story. Here in Ghana, we don't do, if you look at our school system, in the primary schools, we don't really do research. Well, maybe things have changed since I was there, but we don't really do that much research, even in secondary school. So that when you get to the university level and you're doing research, even as an undergrad, really, how much research do we do? And you realize that it has a direct relationship also with presentation skills. Because the more you research and present your findings, the better at it you get, the better at it the better at presenting you get. And I realized that that is also a deficiency in our education. I'll give you the story. When I did my master's in the US, and in my class, I did communication and development studies at Ohio University, and I was allowed, the program was such an open, multidisciplinary or interdisciplinary course that I could take some courses from the undergrad classes, provided it was a level 400 level class, and I had to do extra work. And I could take from a variety of areas, whether I wanted to do media stuff or the communication part or the development part. So I took some classes in public relations. And one of the first assignments, there were three of us who were international students, and we were the graduate students in the class, me, myself, and then a Nigerian lady and now when we were going forward and we're doing just practical stuff, giving us different scenarios where PR is important and your approach to it, I was completely at sea. And this particular assignment, you should have seen some of the presentations those level 400 students made. Lots and lots of color, the PowerPoint, lots of color, very little text. They seemed to be very conversant with what they were talking about, so very little text and all of that. And then by the time we were done, we were the last to present. My team was the last to present. And by the time it got to us, we were feeling quite intimidated and a little unhappy about our situation. Would have preferred to go first. So we start our text. So much text. And because there was so much text and we were kind of reading off, we had done those cards to try to remind ourselves of it. But you see, when your text is a lot, it's all presentation styles. When your text is a lot, you are afraid that if you miss out one word, you miss out the whole thing. And that was a very big eye-opener for me. I think that right from our primary schools, if we learn how to research and present, then it will translate automatically into all sorts of areas. That is a deficiency. And so you see that we don't do so well there. I don't know if you understand the point that it translates. It's right from the beginning. So if you want to make a big impact in terms of linking, of making research and its translation important, or and then whenever you see something, you are curious, you look at it, you study it, and you do you know that whatever it is that you are doing shouldn't stay on your lab shelf. It has to come out. And then you would have picked up how to put across your findings in a way that your audience, whatever your audience is, or however your audience is made up, to understand and appreciate what you're doing. It's because we don't appreciate what the scientists are doing that we cannot support them in the way that we should. So that's why I talked about the communication bit. The practical side, if we understand that the research is important for practicals, before you do anything, you must investigate into it. It will become our way of life. And then it will not have to be such a big subject that we have to talk about, because we are talking about it because it's missing. I hope I answered your question.
Yes, you did. Thank you very much. At this time, I would love to put someone on the spot, but I don't know if it's readily available. So you did mention the fact that there is a need to start right from the grassroots. And there is this organization, We Go Innovate, who is doing something of that sort. Charles, I don't know if you are available. You could just touch on what you are doing at the grassroots when it comes to introducing science, practical science knowledge to people at a lower level in terms of primary schools, JSS. If you are not available, we can take that towards the end. But just to continue, Kofi, now you did talk about some of the areas where collaboration is going on, but we want to broaden it. What are some of the areas that you think would be useful for us to explore when it comes to moving from research to practice in general as a nation? Okay, so we are looking at it within the national context, maybe not just the military. If you have military examples, that is fine. But on a broader level, what are some of those areas that you think as a nation, if we should focus our attention in that regard, we are going to get better return on our investments?
The Navy and coming back. So when I joined the Navy, we had officers always saying that, let's say, those of you coming from the military academy now, you are different, you are not this, you are not that. And we used to disagree because we feel like, I mean, we've spent almost the same time in the academy, like people coming to the same job, commissioned the same way. So, I mean, what's different now? I mean, to be honest, I mean, standards have dropped. Because I've mentored a lot and consistently for about 6 years, I get to meet undergrads, get to meet fresh graduates, get to meet senior high school students, and let's say people who are in their first 2 years in their careers. And for something like engineering, for instance, I realize that so many of them are not abreast with the basic principle, which is very strange. So we always have students coming for attachments on various platforms. And then let's say a machine stops running. A machine stops running and it's what's the first? And quickly, some of them will mention the most remote thing, like the crankshaft, if there's an engine. Then you just think that what if it's just the battery which is disconnected, so there's no power? I mean, and the crankshaft cannot move anyway. So I think these are on the education curriculum sort of thing. But you know, what I also think is that, I mean, even being on this platform as a military officer, I mean, I have to be sure that what I'm saying doesn't represent the views of the armed forces in general. It's my views and my experience and all that. And also have to be politically correct. You don't have to offend someone and all these things. When we begin to talk about education curriculum, it becomes a problem. I've been on education now as compared to, let's say, 30 years ago or 40 years ago, when Ghana was in its prime, and there were so many industries around. For the maritime industry, for instance, I can see on authority that all the ports and harbors we have, including the second harbor, were all built in the Nkrumah era. Thank God today is his birthday, and a happy 112 to him. So you can imagine all those things were built in that era. And in that era, when these things were built, the education curriculum, in a way, was skewed to say, okay, we are educating people so they can go work in this industry, which is already existing. So that was what was going on. So if you were in the, let me say, the nautical college at the time, whatever you were studying was so you could be on a ship in the Black Star Line, which was Ghana's merchant commercial shipping liner. And these things operated for a long time. I mean, when we asked why some of these things failed, we realized that it's because there were no more training students to go and fill in the gaps in those industries. So I think generally as a nation, on a very big, broad picture, what we must look at is our education curriculum. Having to talk to, let's say, engineering students, and you're asking something about a diode, we all want to go into electronics and all that, so it's robotics. But I mean, if you don't know what a diode is, you may not have much business to do with the digital electronic system, because that's like a basic element in that specialized area. So if you're a mechanical engineer, I mean, what are the basics? I don't know what the, so I was at K University probably 2 months ago for their engineering department exhibition. I was impressed a long way to what they had been able to produce, all sorts of things from the aerospace department, mechanical department, the other marine department. I was really impressed. But then when I began to ask questions, basic questions, like someone is doing a 3D printing, I'm asking him, so what is your clearance, your tolerance from this part fitting into that part? And the word clearance is a bit foreign to you. What do you mean by that? I have to go and explain, oh, okay, we do so and so. So you know, when this person has been able to do something, he's printed a drone, for instance. But then when he starts to work with, let me use zip line, because they seem to be leading the drone technology. If it goes to work with Zipline and they have to, let's say, manufacture a part to replace one that got broken because the drone fell down. And for all the education he's had in school all along, I mean, something like precision, clearance is not in mind. He will fit the parts all right, but it may increase the weight of the drone, or it may change the aerodynamics. This drone may not fly like it's supposed to because of, let me say, 0.1 millimeter of a part. So these are things you are supposed to learn in the classroom. And in improving the education curriculum, there must be more practice. There must be more practice. It cannot be that I'm learning about and their region. And then you ask people, okay, so the hull of the ship will change, let's say from the front part, you want a curve or a parabola or something, and you tell them it should decrease by 0.1 of a millimeter at every 1 meter interval. They are a lot to do with the educational curriculum and what we are given to students. And the sad thing is that I have a lot of friends who are teachers. My mother is a teacher, so I was a teacher and I still like to teach. And I feel like we don't have any interest in teach mathematics. But for himself or herself, and this is personal interaction I've had with friends who are teachers, are not interested in the mathematics. But for them to be employed by GES and all that, when they got to their time, they said, okay, we have so many, let me say, social science teachers. So we want mathematics teachers. So for you to be in this training college at this time, 20 of you have to teach maths, 30 of you have to specialize in this, and they jump into that specialization. But they are not interested. So when they are teaching mathematics, I mean, simple tricks that someone who loves mathematics will know. As 9 times 1 is 9, that's true. What is 9 times 2? Okay, so what is the next number after 9 in the descending order is 8. So just write 8 and put 1 in front of it, that's 9 times 2. What is 9 times 3? Write 7, that's the next number, and then put 2 in front of it. And all the multiples, when you add the individual numbers together, they will sum up to 9. I mean, someone who loves mathematics may know this and find a nice way to teach the student. But if the maths teacher during his or her education was just, okay, 20 maths teachers from Mampo Educational Training Center, so 20 of you have to opt to do maths, or else you can't have the addition. They'll do the addition, they'll choose the maths, but they can't come and teach it. They can't communicate mathematics. And for me, that is a problem. Because I want to repeat, I'm meeting so many people, not that they are not good. They had first class and hotnots, studying marine engineering, I studied a while back, and I'll ask them questions about their standards in the industry. So if you know about Bemiston and Wayne engines or Susan, they've never heard about it because it's literally no more in the curriculum now, or even when it was mentioned, it was kicked over, and priority is given over some things, and I don't know for what reason. And you see, this influences some things. I've had conversations with someone like Dr. Yabedi at, I think he's a work pick at the University of Ghana, where he thinks that if we don't fund our own research, at the end of the day, so aside education, I'll move on to us funding our own research as a nation. If you don't fund our own research, someone's interest in, let's say, Netherlands or Spain or UK is different from the interest in Ghana. So you'll be doing a research that may not bother so much to you here in Ghana. It may not concern you that much, but you have the funding because the grant is coming from you or something like that. You go ahead with the research, you finish it. But you may not have so much bearing on Ghana, so you wouldn't be able to of such research. I mean, and so I'm saying there's no offense to maybe anyone who is a research person funded by EU or something like that. It's not an attack on you, but you can confess yourself that, okay, so if I had a chance to do research in my own country, funded by my own government, I may have decided to look at maritime protected areas along the coast of Ghana. Instead of going to study, let's say, marine biology of an area like Miami, where the demographics are different, the ecology is different, the marine mammals in there are different, everything is different. But my PhD and research and everything is centered on a coastline in Miami. It won't be applicable in Ghana. And this is, let's look at our education curriculum and let's see, as a nation, can we fund our own research? Can we fund our own research? We are all seeing the Bill and Melinda Gates Foundation spearhead the malaria research. And I always ask myself, when I look at the demographics for deaths by malaria, how many of them are coming from North America or Europe or Asia? Most of it is centered in Ghana. So at the end of the day, the malaria research has been done. Of course, they'll take samples from Africa, they'll go to all sorts of nations. African scientists will be part of it. And even when you see some of those research papers, the African scientist's name is the fourth or the third one, but he was the one in the field. He's the one who is going through the malaria hassle. He's the one where children are dying from malaria in Africa. But the research has been spearheaded by a foundation, and God bless them, was a good one. But at the end of the day, you may find out that it may not be too applicable to Ghana. Thank you very much.
Thank you very much, Kofi. I think you have a lot to talk about, but when we go into the breakout session, I'm sure they'll have the opportunity to interact with you more. So 1 minute for Nana Ama, just to wrap up, and then Nana Akuia to just wrap up in a minute, and then we can move out to the breakout sessions.
I want to start by saying I 100% agree with Kofi because I think he made very good points on a lot of things that have become issue in industry. Because I look at my side as literally practicing industry, and I hire chemical engineers. And as I described earlier, I am not an engineer, I am not a scientist, and lots of what I did, I learned literally by doing. But I didn't just start throwing things together. I had to research oils and properties of different things and had to learn it. So when I bring in chemical engineers who have graduated tech and other places, and now we are discussing, okay, what happened here and what happened here, and they're literally looking at me like, well, this is your product, so you tell us what to do. Then I'm like, then what did you go to school for? I said, this is where you bring the practical aspect of what you learned in school and you make me better. Because this is where you bring some explanation for why certain environmental conditions make my product look a particular way or feel a particular way or smell a particular way, or why they would change in this temperature, or why this and that and that. That is where your additional education becomes practical in the use in industry. So sometimes it's almost as if we forget that what we are learning in school is what we have to use at work. It's almost like when I go to work, they'll train me, but on what? You come to work with the basics that you learn in school, and then you apply it into the improvement of things. And taking into context everything that is happening within your environment, taking into context everything that is happening within the area that you are, the industry that you are in, all of that. Because if you went into a food industry, the parameters to look at would be different from a cosmetic industry. And the challenge that I have in my industry is that I found out it's not even cosmetic production is not even taught as a course in the engineering schools, because for some reason it's been looked at as something that's a home science thing. But soap making is a science. It's not a try and error thing. There's chemical biochemists around the world who are developing amazing cosmetics in different industries for various things around the world. And that's something we take for granted here because we look at it as, oh, it's just soap. And that's it. But then we are asking for all these things. Oh, we want something for my acne to go and this to go. There's a science behind why you get acne. And so there has to be a science behind how you treat it. There has to be a science behind what ingredients go into it and what chemicals and why you use this one versus that one and what the impact of things when you put on your skin and all of that. So we get so focused on, okay, let's focus on food. And some of that food and stuff research, like Kofi was saying, it's funded by other people. So they are researching foods they eat, but they're doing the research in Ghana because they are using our cheap labor and cheap skills here to fund their projects. And we have to come in and say, well, the food that we are testing, is it Tom Brown? Is it cocoa? Is it a Kenke? If we are not testing these things that are everyday things that we use, then then we are not, what do you call it? We are not improving the way we do things. We are not actually learning and bringing it into industry. We are not actually letting our education become practical in improving the way we do things. So our industries are still old. We are still making things the same way we used to do them. Some people finish school and they don't even help their mothers with their businesses that they've been doing for years to help them. Somebody's mother has been blending, what do you call it? Let's say groundnut paste for years, and they has funded them through school. When they finish, they want to go and work for Unilever, but they're not thinking that I could actually grow my mother's peanut factory, peanut processing, and improve it so that now it doesn't go bad when it sits in these conditions. It can last. We can export it. We can put it in different conditions and different places, and it won't get too hard. All of these things are things that you get to learn in school that your mother didn't know. And that's how you improve it and you make it better. And then that's how we also get to build our own industries in the country, funding our own research, understanding our environment, what happens here, and how it impacts our everyday lives. And that's, like I said from the beginning, it's science is life. It's all the things we do. It's what we eat. It's what we use. The things how we mix our cocoa and how we make our tea and how our Milo became Milo and how our ideal is thicker than our carnation. All of that is science. And why our cosmetic, why shea butter is the way it is, but cocoa butter is the way it is. All of that is science. And they all help us. We have to understand it. We have to engage it. We have to, as somebody says, science is life. It is. It's everything that we do. So we can't ignore it and pretend that you have to go to school to study engineering and do this. And then when you finish, you go to work, you're like, okay, the job will train me. In what? Bring your skills from school. Bring your learning, bring your calculus, bring your biochemistry, bring your oil studies, bring everything you studied, and then use it in industry to improve it. So that's literally what I'll say in my conclusion. Thank you.
Indeed, science is life. I'll also bring my cocoa studies. Nana Ama, final words, 1 minute.
Right, so I would say that one of the things that G.H.Scientific could do is to have, apart from the training workshops I spoke about earlier, to organize maybe seminars or forums or talks or whatever, but to target industry, to target companies, because and this could be something like a forum where potential supporting scientific study and it would help. It would help a whole lot, because there's a lot that people are doing, but there's no noise about it. So it's not out in the general public that this particular project has been done, or research has been done into this area, or this area is being investigated, and these are the things that are coming out from it. It's one of the reasons why Primetime has the STEM Festival, and we have the SciTech Fair, so that the students, what we do, the aim of the SciTech Fair is to help the students to think up and produce local, solutions to our local problems, so that you will find a student from Adas Senior High Technical School coming to the SciTech Fair to show us a fish dryer that they have put together, which is more efficient than the traditional way of drying the fish on mats on the streets or wherever it is that some of the fishmongers dry their fish. So we are trying to let the students, think up these local, solutions to our local problems, and trying to give them the showing, you know, when you do anything and it's in the dark, no one hears about it, you are not going to get support for it, whether the support is material or financial or just, you know, more publicity being given so that everybody can see what you're doing. So I think that there's a lot of room for that kind of collaborative work. But G.H.Scientific, think about this forum that I was talking about, trying to be a hub where those scientists can have some kind of link with corporate, because it's important for funding and for success.
All right. The conversation is getting so interesting. We've gone way beyond the time that is allocated for us, but I want to include everyone. So at this point, we'll be going into the breakout rooms so that everyone can get engaged in the conversation. So at this point, Dr. Tego, can you just give us a brief overview with regards to the breakout sessions, and then we can move in over there?
Yeah,